Why isn't natural variability just like the ice ages? I hear this all the time. We all know in the ice ages there were huge changes in temperature of the Earth as we go from warm to cold. Why isn't this just another one of those things? Well, the answer is what drives the ice ages is our orbit around the sun. It's very subtle changes, and what it really teaches you is that actually the climate system is very sensitive. Those changes take place on a 100,000-year time scale, and we have the orbital elements to predict why they take change. As a matter of fact, right now we should, with that forcing, be headed toward a next ice age in 10,000 to 20,000 years from now. That's why you heard in the 1960s the next ice age was coming. Well, we've reversed that, and we're now moving rapidly toward a much warmer Earth. As a matter of fact, warmer than you have seen in any of the last 400,000 years of glacials and interglacials. We also test our climate models against those very glaciers and the forcing we see from the ice cores and CO2. And indeed, our models predict roughly what the paleontologists tell us that global temperature changed between interglacial and glacial periods. Should we start action now? The answer there again is yes. The lifetime of carbon dioxide we emit into the atmosphere is roughly 100 years. So when you emit something out the tailpipe of your car, it lasts for roughly 100 years. About 200 years later, about a quarter of what you emitted is still there. We, on average, emit per person 50,000 pounds of carbon dioxide into the atmosphere every year. None of us really see it, so you don't see what you're putting out of the back of the tailpipe or from the power plants, but that's what we're doing, and there's no question about what we're doing. We would need to reduce emissions by 60 to 80% today to keep carbon dioxide fixed at current levels. Why is that? It's because of that 100-year time scale. We have not actually seen the warming that we have already committed to at the CO2 levels we're at. Why is that? The reason for that is the oceans are a huge flywheel in the climate system. There's an incredible mass of heat storage in the ocean. It takes a long time to warm it up. And so in actual fact, it takes roughly 30 to 100 years for us to see the full warming that we've committed to. For example, right now, our models tell us there's about another 1 degree Fahrenheit on top of the 1.5 we've already seen that we've already committed to if we just hold CO2 fixed today. There actually is no way for us to hold CO2 fixed today because society needs too much energy to do it. So we need to be starting to get clever early. The longer we wait, the harder this problem is going to get to modify. To put that in perspective, aerosols in the atmosphere, many of you have heard of acid rain, which was quite a problem for a while, which is basically sulfuric acid droplets forming in the atmosphere from emissions, sulfur emissions from mainly coal-burning power plants. Well, when we cleaned that up, that acid rain went away very rapidly. It turns out the lifetime of aerosols in the atmosphere is 2 weeks. So once you stop emitting them, they're gone. 2 weeks later, they get rained out of the atmosphere. CO2 is a well-mixed gas. It does not get rained out of the atmosphere. The only process to get rid of it is for the deep ocean to suck it up, and that's where the 100-year time scale comes from, is the processes that need to take up CO2 are very long time scale and involve the deep ocean. The later we start, the larger the economic and political shocks will be. That's one of the reasons for starting early. People who've done economic studies have given the uncertainties in the science, technology development, and economic impacts. How do you come up with the most robust solution for a society to deal with a problem at this time scale? The answer they get is start modest, start really early, and then as you watch how fast the climate changes, how fast technology developments, how the economic system responds, you then ramp up or ramp down responses as you go. Do not try to pick a perfect scenario from day one. Economists currently estimate that it's roughly 1% of gross domestic product per year to start doing something serious about this problem long term. So it's not going to change your fundamental economic system drastically, but that obviously is significant. 1% of GDP in the US is about the level of effort we spend on Iraq right now in terms of a security issue. So it's significant, but it's not debilitating. So don't panic. But also don't sit there unequivocally waiting for somebody to hit you over the forehead with it. How can I find out more? Some of you may not like Al Gore, but I can tell you from the science community that his Inconvenient Truth movie is the closest thing we've seen to a good introduction to climate science. I would give you 2 cautions about Al's movie. He talks about sea level rise of 10 feet. That's the upper limit of sea level rise. Why does he talk about it, even though the climate models don't show it? The reason is the ice core data. If you go back to the ice core data of the last interglacial, the last time the polar regions got as warm as we think they're going to get 100 years from now, sea level was 10 to 20 feet higher than today. Our models don't yet predict that because I said we can't flow glaciers downhill, and that's mainly the way they get destabilized and move. We are seeing in the last decade the signs that the glaciers are speeding up, especially in Greenland, but we are not yet confident enough to tell you what sea level rise will be in that range. So Al is just showing you the upper bound of where it could go to if the glaciers can respond very rapidly in 100 years. The other thing he points out is hurricane change. There's still a lot of debate in the climate community about how strong and frequent hurricanes will get in the future. So take that with basically being, again, the upper bound of what change could be there. There's a lot of pamphlets here and information you can use. I recommend going to the IPCC report if you want to read these 20-page policymaker summaries to get a better picture and more detail. The other thing is in terms of what you can do, from fuel efficiency of your cars to fluorescent light bulbs, I highly recommend the Energy Star website the government runs, which gives you an idea of what makes sense and not in terms of energy efficiency, and that's a good place to start with some of those impacts. And I'd like to close by saying that when Galileo proved the world was round and it went around the sun, not the sun around us, that was a shock to society. The change in view that we are actually capable of changing the Earth's climate system is an equivalent level shock to us. And we are having a hard time dealing with it, believing it, and moving forward on it. The difference is when Galileo came up with us revolving around the sun, there weren't any actual social economic impacts of that discovery. Unfortunately, this one does have social and economic impacts. So we can't really wait for 100 years while the scientists argue this out to get to 99% certainty in the textbooks to start moving. The scientists are already at the 80 and 90% certainty. I don't think you'd wait in terms of medical treatment to wait for 99% certainty before you did something, and this is kind of an analogous thing. And I'll stop there.